Let's take a look at the graphs of functions and how to apply function notation and interpret it just from a graph. So here we have this function h of x, but actually our first question is going to be, is it actually a function? So what we want to be able to do is, looking at a graph, can we see if it's a function or not? So as a reminder, what we're really looking at is for every input, there is one output. So what that means is that for each x value we have, it should only map to a single y value. What we can't have is like at x equals -2, if I plot a dot up there, this is no longer a function, because then where x equals -2, I have two possible y values, and that can't work. So this is where we think about the vertical line test, which is the idea of imagining every possible vertical line that you could draw on this graph. If you draw all of those lines, you should only cross the graph at most once for every line you draw. If you draw a line and don't cross anything, that's completely fine. If you draw a line and cross it once, that's perfect. It's if you're able to draw a line and you cross it more than once, then it's no longer a function, because then you would no longer have just one output for each input. So yes, because for each of those lines that I drew, it only crossed once. So it passes the vertical line test. Vertical line test, VLT for short. Okay, say I want to find h of 2. So this is telling me my x value of 2, and I want to find out what's the output. So what I'm looking at is, I'm going to go to the graph and look at x equals 2 and find the coordinate. So I have this coordinate x equals 2, y of 1, and it's the y value that's the function output. So that value of 1 is the output for the function. H of -4, so I go to x equals -4, find the y value. So I have this coordinate -4, -5. So that y value of -5 would be the output. Say we switch it around, say we want to solve. So now we have this y equals -5, and actually we already have an idea of a possible solution, but we need to see if there are more solutions. So with B and C that we just went through, it was all about finding this single point, because you have your input and there should be a single output value to match up with it. When we solve and we're given the y value, we want to imagine this horizontal line. So we're looking at y equals -5, so I'm going to have my horizontal line, and I want to find every point where it crosses. Again, when you're solving these equations given y, you can have multiple x values. It's just for cases like B and C where you're given an x value, you should only have one y value. So we have -4, -5. We also have 0, -5. So we have two possibilities for x. So in terms of solving, we would say x can be -4, 0. Those are the two possibilities. For h of x equals +3, same idea. I'm going to go to +3 and imagine this horizontal line and just look for any spots where we cross. So there's going to be this coordinate 3, 3. So there'll be one solution, and that's when x is equal to +3. So that's how we can look at function notation within a graph, and also using the vertical line test to determine whether or not a graph is a function.